Hello, I'm Channa Bankapur. I'm going to discuss my solution to the LeetCode problem, longest substring with at least k repeating characters. It's today's daily challenge in LeetCode. The problem definition has a typo in this in LeetCode. It says less than or equal to k in the end, but it should be greater than or equal to k. Okay, let me rewrite the question. Uh, Given a string s and an integer k, so we need to return the length of the longest substring of s such that the frequency of each character in the substring is greater than or equal to k. Why? Because we need at least k repeating characters, right? So each letter in the substring should appear at least k number of times, right? So let's look at the two simple examples they've given. The first one has 5 characters and k equal to 3. And look at the longest substring here is this AAA because it needs to appear at least 3 times. B cannot be part of it. And take the second example, k equal to 2 here. So the substring having the first 5 characters has 2 A's and 3 B's, so that qualifies. C cannot be part of it, right? Let me take an example, but before that, let me show the solution, and then I'll explain along with the solution. That'll be easier for you to understand. So let me take an example with something like we have a substring where, sorry, we have a string where A appears, suppose that there is a letter A which appears twice and B appears once and K equal to 3. So that means in the substring we are looking for every letter should appear at least thrice. And because A appears twice and B appears only once, the whole string cannot be the answer, right? Because we don't have enough frequency for some of the letters here. So A and B cannot be part of the answer. Even some letters, something like, suppose C appears 4 times, but we don't have a substring having three occurrences of C without having A and B. That's why C also cannot be part of my substring, right? So now suppose I'm going to add few more characters here. Suppose there is a letter called D which might appear 3 times or even more than 3 times. But again, the fourth time whenever we have D here, that cannot be part of the answer because no, A is already in between there. So but we have 3 Ds which are consecutive to each other. In that case, that's part of that's a valid substring. And suppose we have another couple of characters, maybe E and F, E, F, E, F, F, E, F, something like this. So we have a substring here with 7 characters where E appears thrice and F appears 4 times, right? It's not like it has to appear only here. If there are like E and F in the end, that's not going to affect, as in those won't be part of the solution, but we know it appears there. So how do we solve something like this? One thing is, if I know the frequency of each of these letters, that's a good start. Suppose I find the frequency of each of these letters. So A appears, uh, 2 times, and B appears once, and C appears actually 4 times here, and D appears 4 times. E appears, let's see, 1, 2, 3 here, and then 4 times, and appears 5 times. So looking at this, we already know that the whole string cannot be the answer because there is at least one letter that appears lesser than k number of times, right? So once we find that, because that cannot be part of the answer, that's going to split the whole problems, right? Suppose if I look at the first A here, I know that A cannot be part of the answer. So we if we have to as in we may have to just solve for the left part of it and then right part of it, right? So the rest of it. But instead of saying the rest of it, what I'm going to do is, because I know at least at this level, I know A cannot be part of this answer and a B here and a here. So it is as good as I'm splitting the whole problem into these 4 parts. This A and B, because they appear lesser than k number of times, they are going to partition the whole string into 4 parts. And we just have to solve these 4 parts because it's a substring which is the answer, and none of these are going to involve in other subproblems. Each of them are independent subproblems, and that's why this technique is kind of divide and conquer technique now. So I'm going to use divide and conquer here, which appears to be an easy solution for me, right? There are other ways of solving, but I'm going to use this idea. So I'll find the frequencies. So essentially I need to solve for the whole range here. And every time I'm going to divide, so I have a sub range. So that's why I'm going to use a helper function here called F. which is going to start from 0 index and then n minus 1 index. So this is the whole range in the beginning. And this helper function obviously is going to use the subproblems of the same type. So we need a range. So the range is going to be low to high, right? So low and high are the two parameters here, and it's inclusive. So both of these indices are part of the range. All right. So, and also one more thing, if you see, if I'm solving for a problem size of only 2 here and k equal to 3, definitely we cannot have, even if it has only one letter, the frequency of that is not going to be k. So that is obviously not an answer. So that's like a base case for me. So high minus low plus 1 is the size of the range. And if that is lesser than k, so we don't have an answer. We don't have any, the substring cannot be more than of length more than 0. So I'm going to return 0. So this case is easy, so that this problem also returns 0 as the answer. All right. So other than that, so in each of these problems, I'm going to find the frequency of all the characters as I found here already. This is for the first level of problem. And once I have the frequency here, I'm going to go through this loop where I'll keep finding these subproblems of the range, I to j minus 1. Why j minus 1 is because I'm going to find s of j which has a lower frequency, a frequency lesser than k. So I'll go through each of them starting from j equal to low as long as it'll go up to high. So whenever I find s of j, if that frequency of that is lesser than k, it is going to split the problem. I don't know what is the right part because it can have multiple problems, but the left part is very clear. It started with I, and then it's going to end with j minus 1. J is not part of that problem. So that's why I'm going to recursively solve for the range of I to j minus 1, right? So and then I keep track of the max length. Max length is 0 in the beginning, right? And for the next range, I is going to start from j plus 1, right? So that way I'll keep finding the next problems, right? The first problem was from 0 to 1 because j is at 2, and then the next I is going to be at 3 here, so that I'm going to find the next sub problem, right? So once I am done with all of these things, so the last I is going to be this one, which is part of the last sub problem. But I don't get to call that because when j crosses high, I come out of that. So that is not yet solved. But one more thing we can realize when I come out of that, uh, what if there the none of, all of these frequencies are greater than or equal to k, right? In that case, we never find this if condition is never going to be true. That means I never get to change. So if j when j crosses the whole range and I is still low, that means we never got a range, or we never got a letter which has lesser frequency. That means this instruction was never executed. If this instruction executes, definitely I will be more than greater than low. So if I is equal to low, that means the whole string is the answer. All of them has the frequencies. I don't have to check it separately. So if I is equal to low, that means the answer is the size of the range itself. Otherwise, I still have to solve one last problem, last subproblem, which is going to be from I to high, right? So starting from the index I to high. So that is also I need to solve, and then I'm already keeping track of the max length, and that's going to be compared here also. So I'll take the max of those two, and that will be the answer, right? So here are the recursive calls here, right, for each subproblem. All right, so this divide and conquer approach works nicely. And if you see here, other than the recursive part, we are only doing linear, we are only taking linear time. One is here, which is finding the frequencies, and then this one, which goes through all of them. It can be improved further a little bit. So one thing you can observe is, say, once we cross the first subproblem and then go to the second one, the frequency of C is 4 overall. But if you see, there are already two C's we have seen earlier, and that means we don't have four C's anymore going forward. There are only two C's. So that's why C can also be part of, the frequency of C can be reduced. Not just C, any of the subproblems we have seen earlier, all of those, the letters, the frequency of all the letters can be reduced. That way we might, as in we can split the problem even, in a better way, right? But I didn't do those kind of optimizations. If you do them, it'll run even faster, right? Let me run this one and then show how does it look like. This already works pretty good for me. This, look at this, it accepted, and let me see how much time it takes. Yep, it took negligible amount of time, 0 milliseconds here, and this is probably one of the fastest way of implementing. All right. With those improvements, maybe it'll do a little better. But I'm not sure the test cases are really looking for such improvements. All right. So let me know if you approach this problem in any different ways. There are actually multiple ways. I can think of a couple more ways already. So let me know if you have any other approach. It's good to discuss in the comments below. All right. Otherwise, please like the video and subscribe to the channel and keep solving a problem every day. That's good for you. And thanks for watching.